Hello everyone, this problem has been asked in GATE 2013 session 2 and it has weightage of 1 mark. GATE 2013 session 2, it has weightage of 1 mark. So let us see what the problem says. So the problem is consider a delta connection of resistor and its equivalent star connection as shown below. If our elements of the delta connection are scaled by a factor of k greater than equal k greater than 0, the elements of the corresponding star equivalent will be scaled by a factor of, and the options are k square, k 1 divided by k under root k. So from the question we can say that this problem is related to network and electrical circuit subject. And in this figure we are given with delta connection. The another figure is given as a star connection. So first, if you want to have detailed concept behind this problem, you can kindly refer the NPTEL lecture number 55, a star delta and delta star transformation, and the NPTEL course name is Network Analysis by Professor Tapas Kumar Bhattacharya, Department of Electrical Engineering, IIT Kharagpur. The YouTube link is also shown over here. So before we begin to solve this problem, let us have a quick recap about the star delta transformation and delta star transformation. So first, one important point I want to mention here that for the interconversion of delta and star, when all the resistance are same, that if you consider all the resistance are same, we can directly conclude 2 points. From delta to star, resistance will be divided by 3, and from star to delta, resistance will be multiplied by 3. So here you write. So let us prove this point. So let us assume these 3 resistors are in delta configuration. So let us take it as R1, R2 and R3. And now let us take the equivalent star connection. Let us assume it as a small r1, a small r2, a small r3. So if we want to write from delta to star, delta to star, how we can write r1 equal to both the components that is adjacent to r1, that is r1 into r2 divided by r1 plus r2 plus r3. This is the equivalent star resistance value. Now let us assume let r1 equal to r2 equal to r3 equal to r delta. So in that case, if we find r1 and take it as r star, so all the resistance will come equal. R star is equal to R2 equal to R3. We know that. So R star, if you put all this value, then in numerator it will come R delta square, and In denominator it will come as 3R delta. So from here we can say that R star is equal to R star equal to R delta divided by 3 when all the resistance are same. In similar way, we can write a star to delta. Now, if we want to write the R1 value from the star resistance value, then it will be R1 plus R3 plus R1 into R3 divided by R2. So this, if you want to, if you are writing this R1 value, then this adjacent resistor, summation of adjacent resistor R1 plus R3 plus R1 into R3 divided by R2. Here again, if you put this R1, R3, small R1, R3, R2 value as a star, then you can say that R delta is coming as 3 into R star value from here if all the resistance are equal. So from here we can uh, conclude this point that if all the resistance are equal, if you are going from delta to star, then resistance will be divided by 3. So here we have taken, and if you are going from a star to delta, resistance will be multiplied by 3. So let us solve the problem. So here we can see that this is delta connection and this is star connection. If you are writing from delta to star, like, so this is according to this figure. So according to this figure, the equivalent star connection we can make. So this is RA in a star, this is RB, and this is RC. So before we multiplied K value in delta connection, so we will take one value. So this RC we are going to write, or we take this RB or RA, because in a small and capital you will get confused. So let us take this RB value. So how we can write RB from the delta connection? From that we can say the element is adjacent element is RA into RC divided by all the resistance RA plus RB plus RC. So this is the value before we multiplied with K factor. Now it is given that all resistances in delta connections are scaled by K. are scaled by k. That means RA dash equal to k into RA, RB dash will become k into RB, RC dash will become k into RC. These are delta resistance values. So if we write RB dash value that is equivalent to star connection, then it will become RA dash into RC dash divided by RA dash plus RB dash plus RC dash. So RA dash is K into RA multiplied with K into RC divided by KRA plus KRB plus KRC. So RB dash will become K square into RA into RC divided by take K common RA plus RB plus RC. So K will come out. So K into RA RC divided by RA plus RB plus RC. And this is nothing but it is equal to RB dash equal to K times of previous value RB value. So we can say that resistance in a star network also get scaled by the same factor as in the delta network. We have proved here. So the correct answer will be K. That is given in option as B. Therefore, B is the correct answer. That's all. Thank you.